Nope, that's not it. Yeah, yeah. Okay, that's it. Let's just check sound levels here. Yep, confirmed. Everything looks fine and dandy. Sorry I'm late. Things came up. Customers, clients, and they are still. 1 second, sorry. All right, cool. Sorry, clients were just buzzing, and well, cannot just turn them down, right? Well, I can, but I shouldn't because they are my clients. Well, yeah, let's go. So let me put the chat up here. Yeah, chat it up. Nice. So let's carry on. Today we're going to do chapter 10. My God, so dusty. Today, going to do chapter 10, which is managing local users and groups. Today, it's going to be chapter 10 only because of my own time constraints, and I have to do stuff. And this is kind of a long one. I like to spend some time with this chapter 10, which is managing local users and groups. Because until chapter 9, the one we saw the previous session, it was editing text files, redirecting, shell input and output, and all of that stuff. So until chapter 9, it's kind of a we are building our own toolkit, our own processes, the tools we like, get some muscle memory going, right? So we didn't do anything, let's say, very serious with the system in a way. We did not leave the non-previous account user. I always use the student account. So hell, we didn't even leave the kind of the but I don't want to say basic because basic sounds a little bit underwhelming, but you never left the non-privileged user realm, right? So we couldn't do much harm even if you wanted to the system. So yeah, we just stayed with the kind of the non-privileged user environment. So hell, until chapter 9, we did nothing that could harm the system, right? So that's until chapter 9, it's kind of building our own processes and our own methods. And now we're going to go to chapter 10, which is managing local users and groups. And this is going to allow us to kind of build up on that knowledge and get things going. So if you are watching this in the short form, in a vertical format, I'm also streaming on the horizontal format on YouTube and Twitch. So do check it out. So on Twitch, it's twitch.tv/Ozzoy Bits. If you are watching this on YouTube, just go to my long form format and I'm there. If you want to stay in the short form, it's fine. I'm happy having you here one way or the other. If you become a member, even if in the lowest tier, you will be getting access to the edited down version. So all of this intro and fluff and me talking and digressing, you will get that cut out. And if you are a member, even if in the lowest tier, you will be able to see the edited down version of this and get right to the point. And that's exactly what we're going to do. We're going right to the point, which is let me find my correct button. Not. I need to make this in the order. I kind of see it better. Yeah, this is fine. So here you are in the console. As you can see, we have not left the student user. Most of our commands were all done with the student user. We are not even you have not even used the root user, for crying out loud. And we have done so much already. So, oh, wait, I'm doing stuff in the wrong screen. Yeah. So let's go to chapter 10. Chapter 10. Users. Managing, it's fine. Managing users. Local. That's important. Local users and groups. Okay. There's a lot to say. That's why I'm making this session only chapter 10. Maybe we do a coffee break. I like coffee breaks. Do you guys enjoy coffee breaks? I enjoy coffee breaks. And we'll just discuss a few things about this. And chapter 11, I forget. What's chapter 11? Chapter 11 is what? Oh, it's permissions. Okay, accessing files. Yeah, that one, chapter 11 next week. It's going to be also a single chapter day because it's a dense one. It's a dense one, very dense. I was considering doing a more dense sessions, but no, I think lighter sessions is the way to go. I digress. Okay, so before we start making changes and creating stuff and using command and all of that, let's discuss a little, just very, 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 very short about what the user is. I'm sure that most of you guys that are watching this live on Ozzoy Bits channel, you kind of know what the user is and what is his use case and why is it. Let me stop the replay buffer here. I don't need the replay buffer. And yeah, we. Oh, I forgot to start the recording. I will do it now. So welcome to chapter 10, managing local users and groups. And before we start to create stuff, let's discuss what the user and group is. I'm pretty sure most of you that are watching this either live or the members on an edited down version, you kind of have the idea, but let's get out of the way. So in very simple terms, in very simple very simple analysis. For the longest time, most operating systems, Linux or not, they are considered multi-user operating systems. So it means that um, I'll have multi-users. So it means that multiple people are enabled to use this system at a time. So we have, for example, in this case, I have the student user. I will in the future create a couple more users so that people will have different folders to keep their files. For example, the administrator of the system will be able to configure different types of access. So user A can do one thing, user B cannot do the things that user A can, but can do other stuff. So can get things very separated in those type of situations. You can assign different privileges, time slots. You can eliminate altogether that user that maybe is behaving. So you have separate accounts that will allow you to keep everything separated and segregated throughout the use case of the system. This is not a Linux thing only. This is also a Windows thing, Mac OS thing. So this is kind of even an Android thing. So this is very, very widespread since 30 years old, 40 years old. This is always the case. So it's not a new concept per se, but is something that is very, 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 very useful. So you can check the logs and say user A did this, user B did that, and that's only made possible because you have multiple users using the system, so can get things very, very segregated and separated. So well, let's start by this. We have two main in Linux now, speaking about Linux specifically. In Linux, you have two main chunks of users, two main groups of users. And all of those users are identified by what we call a user ID, okay? So this means user ID. It's a very simple concept, which is a number that identifies the user. So for the human eyes, we kind of prefer the name, and that's fine. But for the system, it uses a number. We will check what number it is in a second. Okay, don't worry about that. We'll check that in a second. So for the system itself, the ID of that user, the number, it's what identifies the user, and it's that ID that will allow the system to, in this case in Linux, the kernel to kind of be able to keep things segregated and is differentiated a word? I think it is. So each ID will have a set of properties associated to that ID, and there are many, many options. So we're not going to see all of them in this training. We're going to see a few. We'll see more in the RH124 and the others. So each ID, each user will have an ID, and associated to that ID, it's a name and other stuff, but mainly that a name. Okay, cool. Now we can also specify this one, the GUID. This is group ID. Group, and a user can belong to a group, or user can belong to multiple groups. And groups, it's in the name, right? So a group, it's a group of users. That's basically it. For example, if I have something I want to give a permission or a right, I want to give to many users, and it's the same right for all of those users. Instead of doing it one by one, I can just simply give it to the group, and all the group members will inherit that property, so to speak. So yeah, user ID, it's the ID that identifies the group of the user. Group ID, it's the ID that identifies the group. And then we'll have some users within that group. It's a pretty simple concept, right? It's not mind-blowing or anything of that sort. It's a very simple concept that everybody understands, and we will build on that. So like I said, there are two. Well, I'm going to put two, but actually you can say three groups of users. Groups not in like this, but let's say types of users. Okay, you will understand why I'm saying three in what do you call that? What do you call this symbol in English? Brackets? 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 Yeah, in brackets. So you have two main groups, which is one group it's made of the root user, and everyone else it's the other group. Everyone else. Okay. So these are the two main groups, so to speak, main types. I should say types instead of groups. Two main types of users: the root user and everybody else. Okay. So what makes the root? Let's stop a little bit to think about this concept. What makes the root user root? So everybody knows at this point in time. I feel that everybody kind of knows what the root user is, or what makes the root special. So the root root is also called the super user, right? And it's called the super user for a reason, because he almost has superpowers, which means that he can do almost, well, basically at this point in the discussion, let's say he can do everything in the system, good things and bad things, right? But what does the root have? Let's think about this. What does the root have, or the root has, that makes him root? Don't forget that Linux is basically the kernel. It's a kernel, right? So what does the kernel know about the root user, so that the kernel knows that the root has these special powers? So what is the property that the root user has that makes him root, him or her? Let's not go through that discussion. So what does the root user have that the kernel identifies and says, you are the root, right? Let me just, while you think about this, I'm going to remove my outer jacket because it's hot right now. The weather is cold in the mornings and very hot in the middle of the morning, which is kind of weird. Anywho, so what does a kernel know about the root user? What does a kernel know about the root user? Or what is a property that the root user has that enables him to be treated specially? Do you know? I could put here, I never use this slide. Let me use this slide for a few. give you that excuse. Yeah. So what does the root user have that enables the kernel to identify the root as root and give him all those superpowers that the root user has? It's the user ID, okay? So the root user has a special user ID, and that's what the kernel kind of trusts. So the kernel kind of doesn't give a rat's ass about the username. The name root doesn't really matter all that much for the kernel. What the kernel actually identifies and sees as relevant about the root user and everybody else, it's the ID, right? ID 0 is what makes the root root. How do I confirm this? Well, there are many ways, but the way I prefer at this point, it's by doing ID root. If I do only ID, I see my own ID of the student user, which makes sense. When I do ID root, I will see the ID of the root user. And again, I never left the student account. I'm doing this just as a regular account. So I can see that the root user is ID 0. So there we go. So this is what gives root its superpowers. It's its ID. It's not the name. It's not this. No, it's the ID. ID 0 is kind of the property that the root user have that gives them superpowers. Before you guys ask, because it's something I get asked a lot, is can I rename the root user to something else? Can the root user be called the tour, Everton, for example, or anything else? Yes, it can be renamed, but if you want to do this, do it in a controlled environment, in a virtual machine, for example. It's doable, but I don't think the effort being worthy. But it's doable, especially because there are some Linuxes that some Linux distributions it's better said like that. That the root uses is not root, has a different name. But those distros were built from the ground up. Okay, so those distros were built from the ground up. For that, the root user is not called root; it's called something else. So it was built from the ground up in a fully functional machine like this one here. It's technically possible, but it's just not worth the hassle. If you want something else that is, you can create root-like users. For example, I can create the user potatoes and he or she can be root-like. It's better going. It's much better to go through that route than going to the route of an already functional and installed machine that is working, and try to rename the root user for that system. Okay, I would just I would not recommend that. If you want to do that as an exercise and something to pass some time and get some fun out of it, it's fine. But don't try to rename the root. If you need something, if you need a user call that it's not called root but called something else, just go ahead and create a root-like user that we're going to do it in a few minutes time, and you will learn how to do that. So it's better to create a root clone than create or try to rename completely the root user. But if you want to have fun with that, I mean, be my guest. Linux is free, so have a go at it and let me know how it goes. But it's not something I want to do. And I'm going to sneeze in a second. Oh yes, here we go. Oh wow, it was a good sneeze. Woo! Cool. Yeah. So going back to the root. No pun intended. So the root is root because he has ID 0. Okay, that's what makes the root root. This is just a fact. So the kernel sees ID 0 and the kernel goes, okay, you are root. Here we go. Now, if I check the student user, it's ID 1000. Okay, never mind the rest. That's its focus here. So the student is ID 1000. That's what makes everybody else. So basically there are 2,3 big chunks of users. User with ID 0 makes that's what makes the root root. That's final. That's something I will not discuss anymore. You know this already. So what makes root root is the fact that he has ID 0. That's something factual. This is not the discussion. This is just how things are. So the root is root because he has ID 0. Cool. That's nice. And everybody else has a different number than 0, which makes them something else. So student is ID 1000. And in this system, you can say that the student user is the first user after the root. So I had the root created for me. Then I use the root user to create the student. So this is kind of technically in the system, the first account. If you exclude the root, of course. Student is the first account to be created in the fresh system, and he has ID 0. If this was an older Red Hat installation, I believe until RHEL 7 or 8, I forget now, you will see student 500. That's why I say they can be considered 3 groups. We have the root, okay, which is the first group. It's a group of 1, but it's a group. And everybody else. But there's a gap. Where is ID 0 and ID 999? Well, those are reserved groups. Let me show you. So ID 0 is root. ID 12999 is reserved for special accounts. Okay. And ID 1000 plus, it's for regular users. So what is a special account? An account that is used to start a service, an account that is used to start a driver. So stuff that is happening in the background, but also needs to have a user account created to have some rights on the system. So if you need every interaction with the system needs to have an account for that interaction. So every account in the system, in order to interact with the system, needs to have an account. So a driver, service, script, etc., needs to have an account to interact with the system. And this is not written down in stone, but it's kind of a general rule, a gentleman's agreement that says, okay, these accounts are reserved accounts for special accounts. So don't create a user account within this range. Can you create a regular account within this range? Yes, you can. For example, the student could be ID 500. So you can, it's not technically impossible. Nobody's hindering you to create an account with ID more than 1,000. So a regular account, it's not mandatory to have 1,000 plus IDs. But it was kind of something that was verbally agreed upon. That is, this is kind of the reserve range. Leave this range alone for special accounts. For example, you install the web server. We will do it later. You install the web server, and the web server needs an account to interact with the system. So that account will be ID something between 1 and 999. All right. Can you create an account with ID smaller than 1,000? Yes. Should you? No, unless it's actually very important or you are following some kind of technical paper that says it needs to be 100. If need may be, you can. That's why when you create an account without specifying anything else, we will do it in a second. When you create an account without specifying the ID you want to use, it's going to be 1,000, like was the student. The next account I will create, it will be 1,001. So the utilities that we're going to use to create accounts knows about this range, and it's going to, by default, go to 1,000 plus accounts. So you don't have to worry about too much about it, unless you want to create a special account yourself, which you are entitled to. Just make sure that if you create, for example, account with ID 200, there's no other account with a 200 ID, and there is no future services that you're going to install that will require the 200 account ID. So, but for the one RH124, which is this training we are attending right now, just remember about the three ranges. Don't worry about too much about them. When you are doing the exam, the EX200, they are going to ask you to create user accounts, and they're going to ask you to create your specific IDs. I will show you how it's done. It's very simple. If they tell you to create an account with ID 100, just feel free to do it, and just do what they ask. It's fine. Cool. Now, where is all this information stored? All this information stored is in 3 files: the etc passwd, the etc / shadow, and the etc / group. There are more kind of support files, but these are the main ones we need to discuss here. All right? Cool. Yeah. So, still using a regular account, let's check the contents of the passwd file, and we know how to check the contents of text files, right? And this one, it's completely wordly viewable. Everybody can see this file by default, of course. And how do I read this? Well, it's quite easy. Well, if you want to use VIM, it's also not a bad tool to use, because VIM is going to color code all of this, and you can stick here, it's fine. Since we are a regular account, we cannot change the content of the file. We are a regular account, so it means that you can see the contents, yes, but no changes possible, because we are a regular account. Okay, so that's the reasoning. So let's read line by line. So this line here represents the root user. Okay, and what can we see about this? So the root is the name, nothing special here. This X, as you can see, everybody has an X. What does this mean? It means that a long time ago, the the password was here. For example, if my password of the root user is password, it will be like this. Okay. Now says X because it's just a placeholder. This X, it's doing just nothing. This X is just taking up space. It's used for nothing except telling you that there's a space here. So instead of just removing that column altogether, they kind of said, let's keep it. You never know when you will need it. And kablamo. It makes sense because now you have a location that you can use in the future if needed be. So you don't have to create something new. It's already there. And the password, it's not here. Okay, so the kernel knows this. The kernel knows that the password, it's not there. It's in a different file, and I'll show you in a second. This is about this ID, 00. There we go. This part here in blue, it's just text. Okay, it's super user, the full name, an address. It's called the geckos, whatever that. I forget what geckos means. We can find out. You know how to do this. So let's do man5 +wd, and I can go here, and there we go. In the manual page, you'll see all the fields. I was just explaining. I'll just explain one by one, right? You know how to do this. If you don't know how to use a man page, just go check the previous chapters. So there we go. It's the geckos or geckos, whatever that means. It's an acronym, which it's not. It's okay. General Electric Comprehensive Operating System. Okay, so basically it's just a text, free text. It means nothing to the kernel. /root. /root, it's the home folder. /root, it's a home folder. At this point in time, you know what a home folder is, but I will tell you once more. A home folder is where the user can keep its files. That's basically that in short term. And this one here, which is it's login shell. Okay, it's the shell. What does this mean? Well, you know, every time you log in, you have a shell. I already explained in previous sessions what a shell is. Go and check it out. So bash is kind of the de facto shell nowadays. That's why when a user logs in, it gets a bash spawned to him. So here I have two main shells, the bin bash and the sbin no login. If I don't forget, I'll show the sbin no login thing getting done. Okay, but basically the no login shell, it's a shell that does not allow the user to log in. What does this mean? It means that, for example, oh shit, I need to do something. I forget. Give me a second. I just need to create run a quick script, which is disable. For example, it's not the case here, but if I open this terminal here, I can do student and log in with the student account, right? You guys can see that. Yeah, guys, it's fine. I'm logged in, right? Now, if I check, let me see if I can do this. I need to be root to change the file, but I have to change the file. So never mind what I'm doing right now. Just ignore this step. I will explain in a second. So I will make the change to possibly file. And I'm going to find here the student user. There it is. And I'm going to swap the bash login shell, which is kind of the normal one, to one of these no login things. Okay, I'm going to save. Now, in theory, this should have immediate effects. So student. As you can see, I'm typing the password. The password is correct, but yeah, I'm not logging in. Why? Because my login shell, it's telling me you cannot log in. That's exactly what this login shell is telling me. You cannot log in. It's a special shell that just disables the possibility of this specific user to be able to log in. That's exactly what the name implies. And of course, something went awry. Can you please just let me be? Thank you. Yeah, rel 10 and 10.1, it's kind of, sometimes it goes a little bit berserk. So sbin, no login. That's not what I want. I want bin bash. Now this should have immediate effects. Student, and now I can log in. Okay. Now, one funny thing is, let's if I do this, this does nothing as is. But if it's a kind of made the login shell for a specific user, that user is unable to log in. I'm going to make a special video about this, but for example, let's say I do this. You don't know what that file is. The possible executable, well, at this point you know, but it allows let's say, so if I am a user and I type possible D, this executable allows me to change a password. I'm not going to do that. I'm going to cancel. Okay, Control C is not working, so I just close this off and open up again. So the possibility utility allows me to change my own password and does not require what? Please leave me alone. I don't want to change a password. Oh no. What? I don't want to change my password. That's fine. Let's just log out. I don't care. Boom. Okay. So that executable, the possibility executable, allows me to change my password, either my password or some other user's password. Can you please just behave? It will be so nice if you did. There we go. Start setup. What the? I already done this. Come on. What the hell happened here? I don't want location services. Why is this? Bro, what? Come on. I'm going to restart you. I cannot. I think I can. Well, give me just a quick second. Why? Just why? God damn it. Rel 10 and 10.1 it's still kind of buggy. Not that big of a deal, but quite annoying. I don't want to go through the wizard again. Wow, weird stuff happening. Anywho, if this takes too long to boot, I just spawn a new one. I have a backup machine already up and running. No, it's booting. We are fine. We are fine. I kind of abuse my system, so that's why they kind of go nuts once in a while. They are entitled to go nuts once in a while. I allow it. I'll allow it. And these machines are in a physical hard drive, so don't expect huge performance. Sorry, a huge performance. It just works. What? This again? What? Well, I don't want to do this. Can I just give me my system back? Well, let's create a new one. That's fine. I don't give a shit. Yeah, I know. It's a simple password. I know. God damn it. Just went berserk on me. Skip. Let me check the possibility file since we're here. Yeah, student is there. Yeah, the X Windows just went berserk. That's fine. So let's log out. Well, now we have the user. I was creating in the. I will delete it in a second. So let's log out and log in with the student user. The X Windows system will just GNOME went berserk on me. It can happen sometimes. Wow. Dude. Okay, that's fine. All of this work. Now it's gone. Woo! Holy moly. So I'm not entitled to get the terminal back with the student user? Wow. Just wow. Fine. I can just revert the snapshot. I don't have a snapshot of this machine. Ain't that nice? What the hell is happening here? Well, I will log out and do this and I'll just reset for the next session. I don't want you guys to wait any longer, much longer. I mean, that's weird. Some files got locked. I can work this out with a temporary user. Then I revert I just build a new workstation for the next session. It's fine. Let me get some root access here for a second. Can I this is very strange. I know. So now he's happy. Is he happy? Let's try student one more time. Log out. Wow. Never happened to me before. Weird stuff happening. Can I open a terminal now? No. How the hell is the terminal locked in that step? I cannot control C. I cannot control Z. Wow. This is red. So it means that it should be a root terminal. Woo-wee. All right. That's new. Let's stick with this guy for now on. Then I'll try to figure out that later. Very interesting. Or just nuke the VM altogether. I don't care about this VM all that much. So maybe it's something about the root user. Never mind. I will just stick with this guy and I can just fix it later. So like I was saying, oh, I'm so stupid. There's the explanation. Oh my God. So why did I type this? Again, but that's a good thing I did. Because you can put anything here. Oh my God. I just created my own issue. I'm so dumb. So yeah. So if you do this special executable will just inhibit you to log in. You just, I'm not going to do this to this guy here, but if you put this on the Ozzoy user, you are unable to log in. So I've shown this in the previous step. Even if you, well, I can do this again. So if I go here, that just proves my point. Holy crap. Okay, so if I go as a root user and I edit it out and I go here, let's put this back, bin bash. Now I should be able to log in with the regular user, with the student user, I mean. Student. See, as you can see, I can log in just fine. Now, if I change that again to bin passable D, I log out, I try again. I mean, let's try again. Student. It's completely dumb that now the system is completely freaked out. It works. It's so funny. Student. I'm unable to log in. And why? Let me show you. So by doing this is so interesting. By doing this, the only thing the user can do is change his password. You can't do anything else. That's so funny. Why do I always, every time I show this, I think it's funny? Because it is. Let's see. If I swap to the student user, the only thing you can do is change its password. And now I cannot do anything else with the user. If I try to use the user, the only thing he can do is change his password. His prompt, his shell is the passable D thing in Jiggy. That's so funny. So I forget that I changed. Man, I'm so stupid. So if I try to log in with the student user, for example, let's close this off. Let's log out. That's why it went nuts. I created my own issue. Well, I fixed it also. So student, I type in the student user. I think I mistyped the password, but that's just me being stupid. So let's login failed, blah, blah, blah. Yeah. Now I don't even know if I can log in. Can I? Can I? Well, I can, but if I open a terminal, every time I want to use a shell, the only thing I can do is change the password. I changed or I don't, I get kicked out. And if I want the password again, I cannot do nothing because by giving the user account on the passable D, the shell to be the etc passable D, I can do nothing because the only shell I get, it's a passable D executable. Wow. Let's fix that, of course. Now I can do nothing. Well, I can do this. And go here. I log out. I come back. And everything's fine now. Woo! I created my own issue and I fixed it. Holy crap. Oh. Wow, I still have the Spotify going. Holy crap. Okay, one more. Let's do this. I have 3 minutes to do a short. I need to do a short about this. Well, I can do a short and a long form. I have the replay buffer not going. So start replay buffer. I'll do this afterwards. Well, I can do the kind of the vertical. I'll do this afterwards. It's fine. I'll record this afterwards. But for the guys on the stream, what did I do? I gave the student user the show login shell of bin passwd just to prove to you guys that you can put basically anything here, any executable. So if you put the passwd, it means that the only thing this user can do is change the password. There's nothing else he can do. Is it stupid? Well, kinda. I don't see the point for this in practical terms, but it's hella interesting that you can. Wow. Ain't that nice? That is amazing. So, if you put the no login thingamajiggy here, user is unable to log in, even if he puts the right password. If you put the bash, well, he gets a terminal. If you put here the passwd, then he can log in anymore, because the only thing he can do, well, he can log in, but not to a terminal, because his terminal is the passwd executable. What the hell is happening here? It's dumb, but it's fun. This is a hell of a way to mess something up or mess someone up. Hey, dude, log in with the X user. And he gets that prompt, it goes just fucking berserk. Holy shit. I don't know why I get surprised every time I do this. I know the end result and I still get surprised. Jeez, how nice. Cool. Now, let's check the shadow file. Denied, you cannot check the shadow file. Why? Only the root can do that. So let's go to the next one, which is the etc group. Sorry. So the etc group here, it's where you have, well, groups, right? You have the groups. So let's for example, I think you should have one here. Here's the wheel group. The wheel group, it doesn't matter what the wheel group does at this point. I will explain in later. So this is how you do it. Wheel X, it's a password that is not existent at him anymore. The ID of the group, and then the members. So student and Ozzoy belong to the wheel group. Okay, that is something that happens by default unless you say you can have it by default depending on the situation. Okay, so the only file we were unable to see was a shadow file, because to see the shadow file and its contents, we need to be root. And finally, I'm going to show you guys how to become the root user, how to become root. So in order to become the root user, you can use two methods. One is the sudo method. The other one is the su method. Okay. Su means switch user or substitute user. Many people say that su means super user, which is not true. Su does not mean super user. It means substitute user or switch user. It's substitute user if you want to be really painful. Many people say it's called super user. It's not, because with su, with the su command, you can become any user in your system, not only root. So to say it's super user, it's kind of incorrect. Well, not kind of, completely incorrect. So how do I use this? Well, You just need to do, if you do SU enter, since you are saying nothing else, it will assume that you want to become root, which I did. Well, if you know the password, of course. Or you can do SU and the username, and you can become that user that you specified. Pretty simple. Well, you just need to use you just need to know the password of the user you want to become, and you can become. To exit, Control D or exit, and you are back to the previous user. You have seen probably some people use the dash. Dash is to become the user and be the user, which means by using the dash, I will gain the rights of the user I'm becoming. And with the dash, I will also load all the personal environment files that the user has for him. I'm not going to go into great detail about what these environment files are, because I will explain that in the RH124 in the next live classroom sessions. But by adding the dash, you will not only become the user, but also load all its personal environment files. That's all you need to know for now. So the correct way, in my opinion, is to always use the dash. There we go. Or there we go. So SU, it's a way to become root or any other user. But be careful while using SU. Because imagine this. Let's say right now, I don't know how many viewers are watching this right now, but let's say you have 50 viewers watching this. If I tell all the 50 of all the single people watching this the root password, let's say the root password is potatoes, which is not. But imagine it is. So let's say I'll tell all 50 of you, listen, the password is potatoes of this system. At this point, we have 50 root users because 50 people know the root account password. So 50 people know the password to access this root account. So we have 50 root users, basically. Let's say today at 1 a.m., this system gets borked and I go to the log files of some sort, of some reason, of some method, and the log files say, the root did this. Right now, 50 people know the root password. Which one of you 50 did this? You will never know. Because everybody has a root password, so everybody is a potential root, so we will never know specifically which one of you did that. Because 50 people has the root password, 50 people can log in as root, 50 people can create a big mess in this system. Right? Right. So yeah, that's one way to get root access, is to give everybody that will have that right. I mean, root is only one person, right? But if that, which is me, in this example, but if I give all 50 of you the root password, everybody's root now. 50 root users, that's bad, because the root user can do whatever he likes, and usually to create chaos, right? It will create chaos. But that's one way to do it. The other way is through the sudo. So I'm not going to go into much detail about the sudo right now, because that's for the advanced training. But sudo has a big advantage, which is I can allow a regular user like the student or the Ozzoy user, I can allow a regular user to behave like root, but the password that this user will use is his own password, not the root password. He will never know the root password. In the log files, it will say X user did that. So very specific to the user. And I can be very careful with what that user can do. I can say, you can use this command as root, but that command you cannot. So sudo is kind of the best way to give responsibility to users. You can reboot, you can shut down, you can restart that service. You can be very detailed on which one can do, because if I go through SU, means everybody is root, and everybody who can get SU access can do anything with the system. So if you log in with the root user with the SU account, you can do anything you like, and you never know. Through sudo, it's different. So, like, for example, if I do sudo, I am not root, right? I am just a student. So if I do ID student, right? So if I do sudo, I don't know, something really harmless. For example, lsblk. It will ask for the password, but for the student user, not the root password. Is asking for the password for the currently logged in user. The currently logged in user does not know the root password at all. I type the password for the student user, which is not the root user. He will run the command as root, but never use the root's password, which is awesome. Okay? And at any time, the root user can revoke this. So let's say the student user abused the sudo command. He can just revoke that right. It's really simple. I'll show you next. And it also gets logged. See, it says that the user account student executed this write via sudo. So it will just get logged in, not logged in, but logged into a file saying that the X user used its sudo write and did something and what. So sudo allows for a specific user to run commands as root with his own password, not using the root's password. The root can revoke that write or give it back at any time, and it gets logged. And I can also say which commands he's allowed to use. So I can say the student user can use the lsblk, but not the reboot, for example. So the SU is very powerful, and you can tailor many options with it. So how do I configure sudo? Well, okay, you have two options. You can use a command called sudoers, or edit directly the etc sudoers files. I'm sorry, not this one, not sudoers, not vi sudo, and you can vi the etc sudoers file. You can do both ways. By using this, it will just have a kind of some checking process, some checking routines. If you do a mistake, it will tell a mistake on line X. That's fine, or just go directly. Since I'm lazy, I'll just do this. And as you can see, to edit the sudo, I need to be root. So let's go right to the thing that I want to show you. I will not show you everything. But for example, here percentage will, it's the members of the will group, which the student is a member of, can run all commands on this system. Okay? You also see many times this one, no passable all. This means that if this was not commented out, this is commented out, but if it was not, if this was in use, like inverted like this, if it was like this, it will say it will mean the exact same thing. So all the members of the will group can run all commands, but it will be required no password at all. It just runs and it's done. In your home system, it's fine. In the production system, just require the password is for the best. Or you can use something like this. Members of the users group or any other group, just change the name. And you give the set of commands they can use. Okay, you'll give the set of commands they can use. You can give a list of commands they can. So by doing this, it can run all commands. By doing this, it can run only a set of commands. And it doesn't have to be a group. We can, for example, say student. Oops. Student all. Come on. Cannot type today. I wake up at 5 a.m. to resort to start a customer issue. And then you can just say, you can run the sbin mount, for example. Okay? You don't have to resort to only groups. You can be specific users. I'm not going to tailor all that much the sudo, but in a regular system, the wheel group, you put in the wheel group the members that you can want them to use sudo, and you are all set to go. Then you just can go to the etc group file, and you just say, okay, these are the guys who can use sudo here. Student and Ozzoy belong to the wheel group, and the wheel group via sudo can run root commands. So which one is the best? Well, they both have their use cases. So su, if you know the root password, you can use the su command, which means that if you give the right root password to 100 people, you have 100 root users, basically. If you are very tailored via the sudo command, you can be more detailed about who can run the commands. The users never use the root password. They use their own password. You can provide a list of commands that can use sudo with, and everything gets logged in the secure file. So I would say option A, sudo, it's the safest option. And for the real root users, the real people that are really roots, which should be 1 or 2, then you can use the su. Wow, this was fun. Woo! I love this chapter. It just gets my blood pumping. I just need to use the bathroom really quick. Let's do a quick coffee break, 5 minutes, and we come back to the other part, which is kind of the easiest one. So this was the complicated thing. What is a user group? So blah, 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 blah. Now we just go to the commands, which is the kind of the easy part of this. Let's do a coffee break. I need to take a pee, and we'll come back in 5 minutes time. I'll see you then. Oh, the microphone was off. Now it is on. Cool. Let's go here. Cool. Lots of fun we had this morning. Very, very, very nice. Let's check the chat. Check the audio. My mic was off. Cool. Yeah, everything looks fine. Yeah, again, people spamming my Twitch chat for no reasoning. Okay, now we know all of that. So let's go ahead and go. Well, now you know if you should rewind this if you're watching this not live, and I'm going to keep the VOD on the YouTube channel, and I'm going to also edit it down for members so you don't have to see the coffee breaks and me chatting. But we saw what is a user account, how do I identify its user account, different ranges, how do I define a login shell, what different login shells and the effect they have in the user account. We had some fun with non-standard user account, login shells, and all of that. Good stuff all around. Cool. Now let's go to the easy part, which is let's create an account. I mean, that's the easy part. Let's create an account, create a group, and give the people a password. I mean, that kind of it. The fun part is gone. Now it's just standard stuff. How do I create a user account? Well, to create a user account, I need to be root. Now you know the methods. You can use su or sudo. I'm going to use su because I can. Now, you can use the command user add or add user. Okay, you can use both. Now pay attention to this. In Red Hat systems, the user add and the add user commands do the same thing. In RHEL systems, the user add and the add user are basically the same thing. Check this out. Let's see, for example, which user add, which add user. And let's do a long list to both. As you can see, basically, at this point in time, you know what the soft link is. If you don't, go check the previous sessions. This one is that one. So the real one, quote unquote, the real one is this one. And the add user just kind of calls the real one. Okay. But if you are in a Debian Ubuntu system, for example, there are different commands with different reasons to exist, and they do different things. Okay, so in RHEL they are the same command, but in other systems they may not be, and in different systems they may do quite different things. So just be aware of what system you are currently doing your stuff, because even though in RHEL they are the same command, it's not like that in every situation, in every scenario. Okay. How do I create a user? Man, it's just user add. Let's create an Alice. It's done. Okay. Cool. Now, there it is. Alice, password is not here, the ID, home folder, and the login shell. As you can see, its student was the 1001, 171, 172, and it will just create it for you. You can tweak this. I will tweak this in a second. Now, since we are root, we can finally check the shadow file. So let's compare Ozzoy, for example, to Alice. User account. This is the password. This is a very, very strong password hash. This is not an encryption. This is a hash. I have a video on my channel about hashes. Go check it out. And this is telling me the password properties. We can extract this information in a more usable, readable form. But it's telling me the password valid, how long will the password last, and when will the password be needed to change. But you don't have to know this by heart. You can just go to the man page. But I can detect a couple. So this one tells me that this user is going to be warned 7 days before the password expires that is going to expire. And this is the password validity, which is infinite. This is the max. But we'll check this out in a second. And also here to the other user. Now, differences. As you can see, Alice, instead of the password, it has an exclamation mark. That's because Alice never had a password. So you need to give Alice a password. And as you can see, since I'm doing this as a root user, this is merely a warning. If it was Alice defining her own password, she will have to create a complex password, like uppercase, lowercase, numbers, characters. But since he's a root doing this, he can just give it whatever password. He gives him a warning. But then you say, Alice, listen, this is your temporary password. Please choose one for you, okay? Or you can force Alice to do that by using the change command. So you can say a regular user, go and change the password so something safer. They never do, right? You can force it. How? Well, you can use the -d command. If you put -d0, it's forced to change. So let's do that. So this is a regular password. So let's do change -d0 Alice. If you check this out, it kind of seems very inconspicuous, but here you'll see a 0 there, see? This means if I do change -l Alice, is telling you password must be changed. So the next time Alice logs in, she will be forced to change the password, which is kind of the standard. So to create a user account, you kind of do this. You add the user, give the user a password, and force it to change in the next login. It's kind of the recipe. Create, give it a temporary password, and force the user to change the password on next login. That's kind of the recipe, and so on and so forth. Okay. So Alice is here in a possibility with a regular shell. Alice is here with a regular user with a defined password, and everything everybody's happy. And I mean, that's that really. It doesn't really take that much. Let's create a different one. User add Bob. Let's create Bob. But now we're just going to create a couple of specials. I mean, you don't need much. So let's just give him a different ID. For example, in the exam, they say Bob needs to be ID 2000. Okay, there we go. Done. Bob's there, no password. We'll give it in a second. And Bob, it's ID 2000. No big of a deal. Possibility Bob. And the exam, they say password must be X. You give it a password. And they probably say force the user to log in to the next login and just go blah, 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 blah. Bob. All good. You're done. Easy peasy lemon squeezy. That's basically it. To create a user, group add. Let's say var referee. Group is created. Let's verify. It's something you already know how to do. Referees has no member. So if I want to put Bob here, you can just VI the file and put Bob there. So I'm going to put Bob here in a one way, using one method, and then Alice using the other method. So let's go user mod -ag Alice referees. It's the other way around. Makes sense. This means append to group, which means that Alice will still belong to every group she already belonged to, and it's going to be added to the referees group. If you don't put the A, if you do this, she will exit all the groups and belong only to the referees group. Or you can just go etc as root, of course, etc group. And just add Bob. Same shit. That's the ID Bob. Bob belongs to the referees. ID Alice. Alice also belongs to referees. Easy peasy lemon squeezy. Now, just to wrap things up, there's not nothing else to add to this. Every user belongs to his or she own group. So there is a Bob group where Bob belongs because it has the same ID. There's an Alice loop that Alice belongs. It has the same ID of the user. So Alice has ID 1002. Her group, it's called the private group. Her private group, where she belongs, has the same ID as the user ID. And there are exceptions to this. Well, you can pick the possibility here. There are some groups, some special accounts that belong to that lower range from 1 to 999 that have some weird combinations. So basically, the shutdown user, for example, belongs to the root group. Leave it as is. Don't change this. This is needed for the shutdown command to be used as the shutdown command. So remember this, IDs from 1 to 999, and there are other exceptions, but let's leave that out for now. From 1 to 999, leave them alone. Unless only change stuff there if someone tells you specifically to do so and give you detailed instructions on how to do it. Okay? Don't touch those users. I shouldn't even be showing you this. So this is a private. Alice belongs to her private group. Bob belongs to his private group. Okay? That's normal. The why I will show you in the next chapter, more specific whys next week. But every user automatically belongs to his own group, and that's expected. Don't change that or else you get problems. There are some special use cases, but for now, just let them be. Sounds nice? Sounds nice. Well, woo! Lots of fun we had today. So basically, we learned what the user is, what a group is, how to identify different users, user IDs, group IDs, create login shells. Watch this over and over and over again. I'm going to deliver throughout the year more live classrooms of this topic, because one thing is to watch the recording, another thing is to watch it live. But for now, watch the VODs. If you are a member, you will get notified. You will be allowed to watch the edited version without the coffee breaks and jibber jabbers. If you're not a member, you can watch the VOD at all the time that you want. You can repeat and repeat and repeat. If you have any questions, ask in the comments of the VOD, and I'm happy to reply. If you are a member, you'll get notified of a new upload of the edited down version of all of this without the jibber jabber and blah blah blahs. Like, subscribe, hype, and comment. And I'll see you in the next one. Cheers, guys.